HDTX to identify the problem. And this analysis goes over the whole link. So the HDTX goes over the whole cable, and from the connector at the main to the connector at the end, including the cable. The rules of testing says that to make sure that your connector is having proper results, the values should be in the range of 17.5%. So if my connectors, if the variation of the connectors is outside this range, meaning I have a problem at that connectors. And an example of that, this analysis showing a value of 42.8 at the end of the cable, so at the remote. So I know from here, if I have a failure in next at the remote, that my problem is a connector at the other end, because 42.8 is way above the 17.5% range that I can have. This is how you decide that you need to re-terminate the connector at the other end or replace the connector. This is how you identify the fault. So you don't re-terminate the connector at the main, which does not need a re-termination. It is good. It's not bad. The bad is at the other end. This is on the connector side. On the cable side, also the HDTX will tell us that the range, acceptable range of variation in the cable should be in the range of 5%. Any excess of 5% means that the cable is bad. So if we have something like this, we know that there's a failure in the cable because of the excess. We're jumping above the limits of it. But this result shows 0.4, meaning that everything is fine because we're still in the 5% range. But if we cross the 5%, definitely we're in that situation. The cable is bad. So, having said the HDTX is a tool to help us find the reason of the next failure. We said there are two types of analysis we do, either the connector, which should be in the range of 17.5%, and the cable, which should be in the range of 5%. Now, if I look at this graphics here, what do you think there's a problem? Do you think there's a problem or no? What you see here is what? Is a connector, cable, something happening here, and at the end, definitely there's a connector.
It's a patch cord. It looks like a patch cord.
Looks like a noise. There's something happening here.
Noise, yeah.
The first thing, if I look at this, if I don't know the network, I need to ask the IT manager or whoever is responsible of the network, if I'm coming just to investigate a failed link. What is the thing you have on your network? The IT manager might come and say, I have a consolidation point on my network. A consolidation point on the network means that there's a termination between, an additional termination between the main and the remote. I have a connection somewhere at a certain length. Automatically this means that there is a connectorization here, and at this time if I know that there's a connectorization and I'm within the limit of 17.5%, means that my link is okay. If there's a bad value here, then we will know immediately that there is a poor termination that I need to re-terminate if there's a bad result at the connector side, at the consolidation point side. Now, this link, what does it show?
Cable.
It shows a cable. What? What do you see about the cable?
Out of the range.
Normally it is out of the range. That's the first problem. And second, the length. What's that the length? What's that the length? You can get... Okay, please, thank you. Because sometimes people forget about this, they focus on this. We have a problem with the cable? Yes, we have a problem with the cable. But even if we fix the cable, we change the cable, we still have a problem of 200 meter.
Just one comment here I want to make, just for you to know. If you see, here. Okay, if you see here, if you want to know exactly the location, all you do is just move the cursor to this location. Then you know exactly at what length this occurred.
Yeah.
So that's why there's a variation here. It says at the 28 feet, I see minus 3.5. This doesn't represent here. So you need to move this cursor to here to see the value of the distance. And this is the percentage and this is the distance. Sorry.
Thank you. So in order to make sure, thanks Mike for that, in order to make sure that this is proper, you need to, with the cursors, move that bar to the right location and see if you're still within the acceptable range of 17.5 or 0.5 for 5% if it is a cable. Now, this is when it comes to next failures. What about insertion loss? What about ghosts? This is where really we have, also on return loss, this is really where we have to use the HDDR, not the HDDX feature. Now, if I look at the first graphics here, I can see that I have a negative margin, I have a minus margin at the 10.3 megahertz. Is it that normally the 10.3 megahertz happens on the beginning of the cable or at the end of the cable? Where does it normally happen? The 10.3 megahertz.
It should be all over the cable.
Who said end of the cable? It's wrong. It is right all across the cables, because frequency, the cable is supposed, or the cabling system is supposed to work with the frequency range of the category it's being installed. If you install the Cat6 cable, the connector and the cable, whole cable should work in that whole frequency, not the first 5 meter or the first 10 meter. So, the value here is 10.3 megahertz is somewhere on the cable. We don't know where. If I use only the results that I get from the return loss, it's not enough. I know I have a problem at 10.3 megahertz, but where? This is where we need to go to the analyzer, the HDR analyzer, to find out the location of the fault. And based on that, when we get this, automatically we will be able to come to a conclusion that the whole thing that I can see here is beyond the 0.8%. So even at 35 meter here, I can see that I have a value of 1.5. So this is where we need to investigate the location of the problem. If I have the whole cable beyond 0.8, that means my whole cable is bad. If I don't have that value beyond 0.8 except on a certain location, means that at that particular length, at that particular position of the cable, my problem is there. So these are tools available for you within the equipment. This equipment is extremely intelligent. It has all the features and the capabilities. And that's what some people say, as Vernon was saying in the morning, sometimes people say it's a little bit expensive. It's not expensive compared to the features that you get. These kinds of features are very unique. To tell you the location of the fault, the problem at each meter, this is something you don't get in other vendors. And this is something that really can save your life. Instead of spending and wasting time on the side fixing problems which are not really the cause of the problem. So, if we look at a return loss, we see that at 70 meter here, I have a problem, I have a bad results here. With experience, with more trainings, with what we teach in the CCTT training, you will come to know that if this happens in the cable and when using the return loss tests, that means that there is a bad section on the cable, that this particular point of the cable is bad. How it can be bad? Probably installation, probably something wrong in the manufacturing of the cable. It can happen. So you can from here know where is your problem, and then you can go at 70 meters of the cable to see what is happening. Maybe an excess bend, maybe a heavy bend on the cable happening, so you can try to analyze the root cause of the problem. Okay, now, to make sure that you will use these features, we need to ask you about these features. So, we talked about next. What are the cause of a next failure?
Split pair.
Crosstalk is next. What is how next happens?
Split pair.
Sorry?
Split pair.
Split pair. Can you write your name?
Termination. Bad termination.
Sorry? Untwisting. Write your names, please. Bad connectors.
Adapters, consolidation point.
It can be, but it's a termination if it doesn't consider.
Split of pairs.
Split of pairs. Okay.
Manufacturer problem.
We have no. It's not really the next manufacturing problems. Normally, it's mostly a site conditions rather than a manufacturing.
Sometimes that twisted pair is not proper from the manufacturer.
If you're buying a very weak cable, yes, it might happen. But if you talk about good brands, it's mostly a site problem. If you're talking about reputable brands of cable, next is mostly a site issue. Now, in HDTX, we said HDTX can help us identify a problem on the connector and the problem on the cable. When we're talking about the HDTX on the connector, what is the limit that we're talking about? 1% at a time. Write your names, guys.
17.5.
17.5, that's excellent. Now, this is where we try to find the fault, and we find it out at this particular length, because it's more than 17.5. And the last question,
5%.
I didn't say the question. Maybe 0.8. The HDTX
5%.
on the cable, what is the limit we're talking about?
5%.
5%. Thank you very much. Whoever had answered that, please write your names and deliver the small paper to one of our team to participate in the raffle. And thank you very much for being in this session. I think it's now the time for a break. I'll leave the mic to Mike. I leave the mic to Mike. It's an interesting one.
Yeah.
So you can explain about it a bit before we go. Thank you very much.
Thank you very much.